Okay, so today we're going to be looking at section 4.5 again, but today the focus is on factoring. So nothing new in terms of the differential equations, but we may see some more complicated characteristic equations to solve. So here we have a third order differential equation. So the characteristic equation here will be r cubed plus r squared minus r minus 1 equals 0. So this one's more complicated because we have the higher order term and the constant term. So we don't get away with factoring out an r or an r squared like we did in the previous examples. So one trick for doing this, we're sort of guessing what the root is, but something can give us some guidance, and it's from algebra, and it's called the rational root theorem. So you can look at the leading coefficient here for r cubed, the higher order term here, and then the coefficient, the constant coefficient here, -1. So we call this a sub 3 the coefficient of the r cubed term, and a sub 0 is the constant term. So a sub 3 is 1, a sub 0 is 1. So what are the roots of 1? They're plus or minus 1. So that's what we do here. So the possible roots in this problem, you take a look at the factors of a sub 0, which are positive 1 or negative 1. Same thing, the factors of a sub 3 are also positive 1 or negative 1. So if you take the quotient there, all the possibilities are positive 1 over positive 1, positive 1 over negative 1, negative 1 over negative 1, negative 1 over positive 1. And really all you're getting from those are 1, minus 1, 1, minus 1. So all the possible roots are just negative 1 and 1. So let's guess what one of the roots may be. So what if we put r equals 1 into our characteristic equation here? What do we get? So we have 1 cubed plus 1 squared minus 1 minus 1. And that's just coming from plugging 1 in for r. So what does that add up to? You have 1 plus 1, which is 2, minus 1 minus 1. That does give you a 0. So that tells you that r equals 1 is a root. So what does that mean? Well, we could do long division to find out what's left over if we divided this characteristic expression here by the factor r minus 1, or we can use synthetic division. So if you're not familiar with synthetic division, we just write down the coefficients from our characteristic equation. So notice 1 is the coefficient of r cubed, 1 is the coefficient of r squared, negative 1 is the coefficient of r, and our constant term is negative 1. We write those down. We put our root that we just found, which was r equals 1 here. We bring down this 1, multiply these two terms together, put that number here. So we multiply these two numbers and place that number here. We add to get 2. Again, multiply 1 by 2, place that number there, add, that gives us 1. Again, multiply, that gives you 1, and add those numbers. And that gives you 0. That tells you that r equals 1 is a root. If you don't get a 0 there, that means you've made a mistake along the way. It has to be 0 if this number is a root. Okay, so what do these numbers stand for? The 1, 2, and 1. Well, this is the coefficient of r squared. This is the coefficient of r, and that's your constant term. So what the synthetic division process tells us is you can rewrite your characteristic equation. You factored it. If r equals 1 is a root, the factor is r minus 1, and then what's left over? R squared plus 2r plus 1, and that's what we have there. So we are almost finished. We're just trying to factor the characteristic equation, and we recognize this as r plus 1 times r plus 1. So let's take a look at the next page. So here we had, this was the original characteristic equation. We got it this far with synthetic division. Now we can factor this part as r plus 1 times r plus 1, which is just r plus 1 squared. And that's the multiplicity. That just tells us that this root that comes from r plus 1 is repeated. All right, so here's our characteristic equation in factored form. R minus 1 equals 0 gives us the root of 1. And what does r plus 1 squared equals 0 tell us? It means the root r equals negative 1 is repeated. So there's two of those. So remember, we're solving a third order differential equation, and we'll need 3 solutions. And what are those solutions? Well, for this root of 1, we have the first solution is e to the t. Then we have the root of negative 1, so for that root we have the solution e to the minus t. It's repeated, so the next one is t e to the minus t. Remember, we just multiply by t. So notice we have 3 solutions. And so our general solution is just the linear combination of those 3. So c sub 1 e to the t plus c sub 2 e to the minus t plus c sub 3 t e to the minus t. So that's our general solution for that third order differential equation. All right, let's look at another one. So this time we have another third order differential equation. Now, here's the characteristic equation. R cubed minus 2r squared minus 9r plus 18 equals 0. Now, if we use the rational root theorem to help us guess our roots, so we're looking at a leading coefficient of 1. Our constant term is 18. Now, the factors of a sub 3 are just plus and minus 1. But what are all the factors of 18? You could have plus or minus 18, plus or minus 9, plus or minus 6, plus or minus 3, plus or minus 2, or plus or minus 1. And again, if you take these roots divided by plus or minus 1, you really just regenerate that list of factors for your constant term. So these are all the possible roots. So we just have to guess one. And we usually start out with the smaller one. So what if we guessed r equals 1 as a root? What happens when we plug into our characteristic equation? So we get 1 squared minus 2 times 1 cubed minus 2 times 1 squared minus 9 times 1 plus 18. Now does that add up to 0? No, it adds up to 8. So r equals 1 is not a root. What if we guess 2? There we'd have 2 cubed minus 2 times 2 squared minus 9 times 2 plus 18. Now that does add up to 0 because we have 8 minus 18 plus 18. That gives you 0. So that means r equals 2 is a root. Okay, so now we want to see what happens when we factor out the factor r minus 2. So we put the 2 here in this box. We write out the coefficients from our characteristic equation. So we have the 1, the minus 2, the minus 9, and the 18. That's what goes here. Now, you bring down the 1, you multiply, put that number there, which is 2, add them, that gives you a 0. When you multiply 2 times 0, you get 0. Put that number there, add them, get negative 9, multiply. 2 times negative 9 gives you negative 18. Put that number there. When you add them, you get 0. So that tells you that r equals 2 is a root. Okay, so what's left here? That 1 is the coefficient of r squared. There's not an r term because that coefficient is 0. And then the constant term is negative 9. So based on what we get from synthetic division, we have the factor r minus 2, because 2 is a root, so the factor is r minus 2. We get r squared minus 9. And then we have something easy to factor. That's a difference of squares, r plus 3, r minus 3. And then we have our roots, 2, negative 3, and 3. We know our 3 solutions associated with those roots. E to the 2t, e to the minus 3t, and e to the 3t. And we just get our general solution like we always have. Just take the linear combination of those 3 solutions. All right. So when you look back, you could have guessed a root of negative 3 or a root of 3, and you would have gotten the same results. Okay, let's do another one. Now, one thing that could be helpful, I don't know if you've ever seen Pascal's triangle. It's sort of a neat thing. This gives us some easy factoring help. So if you look at Pascal's triangle, it works like this. You put a 1 here, a 1 here, and a 1 here. You add these two numbers, that gives you 2, and you put the 1s on the ends. You're always putting 1s on the end. So you put a 1 here, you add these two numbers, you get a 3. 2 and 1 gives you 3. Put another 1, add these two numbers, you get 4. Add these two numbers, 3 and 3 gives you 6. Add these two numbers, you get 4. And there's your 1. Put another 1 here. Add these two numbers, gives you 5. Add these two numbers, you get 10. 6 and 4 gives you 10 again. 4 and 1 gives you 5 again. And put your 1. You could just keep doing this for as long as you want to do it. But why is this interesting in terms of differential equations and factoring characteristic equations? So if you look at this row right here, 1, 2, 1, think of that as the coefficients in your characteristic equation of order 2. Notice r squared plus 2r plus 1 is the same thing as r plus 1 squared. Look at the next row. If you think about that as coefficients of a third order equation, r cubed plus 3r squared plus 3r plus 1, that's the same as r plus 1 cubed. And you can just keep going down the rows to do this. So take a look at this fourth order differential equation here. So here's its characteristic equation. r to the fourth plus 4r cubed plus 6r squared plus 4r plus 1 equals 0. Now that comes from this row, notice. And so if the previous row is r plus 1 cubed, this row is the same as r plus 1 to the fourth. And that's what that's equivalent to. What does that tell us in terms of differential equations? Well, r equals negative 1 is the root. And how many times is it repeated? 4 times. It's a fourth order differential equation. We need 4 solutions. What are they? The root's negative 1. So we get e to the minus t, multiply by t, e to the minus t, multiply by t again, t squared, e to the minus t, multiply by t again, t cubed, e to the minus t. Take the linear combination of those 4 solutions to get your general solution. So this is more like a little trick. When you have characteristic equations that have these coefficients, just go by the row and figure out whether it's r plus 1 squared, r plus 1 cubed, r plus 1 to the fourth. This will be r plus 1 to the fifth, and you could just keep going. So that's just a little trick for factoring. All right, so next time we'll move into doing problems in section 4.6.